Our planet is the greatest living puzzle in the universe. A collection of worlds within worlds. Each one a self-contained ecosystem, bursting with life. But how do they work? The intricate web of relationships and the influence of natural forces makes each micro-world complex and unique. So to discover their secrets, we need to explore them one by one, untangle their interlocking pieces, and ultimately reveal the vital piece, the key to life itself, hidden deep within each of nature's microworlds. In the heart of the Australian continent lies a vast red desert. Isolated for millions of years, its time-worn landscapes are instantly recognizable. Most of its animals and plants do not exist anywhere else on Earth. It's a world of extraordinary beauty and diversity, but also a land of surprises. 70% of Australia is classed as desert, an area larger than Europe. At the very heart of this vast arid region is an area known as the Red Centre. Millions of years of baking sunshine have oxidized iron deposits in the soil, turning them red. It is, in effect, rust. The Red Centre's most iconic landmark is Uluru, previously known as Ayers Rock. But the vast majority of this micro-world consists of spinifex grass and sand dunes. It's a harsh, hot, dry place, parched by the sun, scorched by fire, and prone to unpredictable flooding. The first explorers to travel here thought it a god-forsaken place where no life could possibly exist. How wrong they were. 22 species of mammal, 60 species of lizard, 200 species of bird, and countless insects inhabit the arid centre of this continent. For somewhere so remote and dry, it teems with life. A whole host of marsupial mammals live here, from the tiny planigale to Australia's largest herbivore, the red kangaroo. But it's the reptiles that dominate. Thorny devils, goannas, dragons, skinks and geckos all thrive in the Red Centre, as does the world's most venomous snake, the inland taipan. Even more extraordinary is that here in one of the world's driest deserts, water-loving amphibians live and breed. The question is, why? How come so many unique animals thrive in a place where the odds are so clearly stacked against them? To answer that, we must travel back in time. Before it became an island, Australia was part of a supercontinent called Gondwana. This enormous landmass consisted of Africa, South America, India and Antarctica. When Gondwana broke up, Australia drifted away, and its plants and animals were left to evolve in complete isolation for 50 million years. The results speak for themselves. Take a look at the red kangaroo. There is nothing like it on Earth. They're the largest of all marsupials. Males can stand up to 2 meters tall and weigh almost 90 kilos. It's an unusual mode of transport, but red kangaroos can hop at speeds of over 56 kilometers an hour. With a single bounce, they can cover 8 meters of ground and leap over 2 meters into the air. Red kangaroos are mostly active early and late in the day. Temperatures here regularly exceed 40 degrees, so they conserve energy by resting in the shade. They also have a unique trick of licking their forelegs, allowing their blood to cool through a special network of capillaries. As the day comes to an end, they move out into the open again. Play fighting is common among males. They're constantly jostling for dominance. To show who's boss, they push themselves up on their strong tail to make themselves look as tall as possible. However, if that doesn't intimidate an opponent, then a fight breaks out. Their powerful back legs and claws could easily inflict serious injury, but most of these bouts are friendly. As well as kangaroos, there are many other unique animals living in the micro-world of the red center. Not only are they unique, they're amazingly diverse. Why is this? To understand this, we have to look at a series of events that have had a profound effect on Australia, making it what it is today. We can see evidence for one of these 300 kilometers from Uluru itself. These are the McDonnell Ranges, the remains of mighty mountains eroded to little more than hills. On the rare occasions that rain falls, it's soaked into these porous rocks. And at their base, permanent springs form, creating oases in the middle of this vast desert. Here, in an isolated gorge, it's wet enough for palm trees to flourish. Red cabbage palms. The only other populations of these trees are found 1,000 kilometers away in a rainforest on another part of the continent. But their seeds cannot disperse over large distances. So how could these palms possibly have colonized areas so far from each other? The clue is in their age. Cabbage palms have been in Australia for tens of millions of years. The isolated pockets found today were once all part of the same population. Australia was at one time completely covered in lush forest. But as the continent travelled north, it moved into a zone south of the equator, dominated by high pressure, and the once plentiful rains stopped, creating the desert we see today. The ancestors of all the animals now living in the red center came from this ancient rainforest. That is why there is such a big variety here. But why didn't they just die out as the land dried? How do they all survive here? The waterholes around the central ranges are a haven for life. For flocks of birds, desert water is a lifesaver. Corellas, galahs, budgerigars, and zebra finches flock here. But it's not without risk. Thirsty zebra finches find safety in numbers, but they have to be wary. To increase their chances of catching a meal, these brown falcons work in pairs to cause panic and confusion. Even so, a meal is hard won. And in this case, lost to a white-necked heron. Trees lining the banks attract large numbers of red-tailed black cockatoos. Travelling in flocks, these sociable birds are intelligent and long-lived, 50 years is not an unusual lifespan. The characteristic hollows found in red gum trees make excellent nesting sites. Every year, a pair of black cockatoos rears just a single chick. Both parents are kept very busy. It will be 3 months before it can leave the nest. The ancestors of Australia's birds lived in the large, lush forest that covered the continent more than 20 million years ago. As the continent dried, they've evolved into different forms, specializing in feeding on different fruit and seeds. Permanent desert springs are a welcome oasis, but they only make up a tiny area of the red center. Elsewhere in our microworld, things are very different. The red center is dominated by high pressure. Skies are cloudless, and water is a very precious commodity. However, it does rain here, but there's no way of predicting when that might happen. Australia is under the influence of El Niño from the Pacific. And El Niño is responsible for dramatic and random changes in pressure over the continent. The results can be spectacular. Rain, and a lot of it. So unlike most deserts with a predictable wet season, the wet periods in the red center can be years apart and completely unpredictable. Even in the face of such uncertainty, animals have evolved to cope. Some you would never even know are there until it rains. Spadefoot toads. The ancestors of these toads were tied firmly to water. But over millions of years of drying, they've adapted to live in the most hostile of places. They have only a short time to find food and mate before the relentless sun bakes the desert soil hard again. Kangaroos too take advantage of the good times. During intense periods of drought, kangaroos do not breed at all. All their energy is put into survival. But when the rain falls and there's plentiful greenery to feed on, their minds turn to breeding. During the good times, a female kangaroo might be attending to 3 young at one time. A joey out of the pouch, a young joey in the pouch, and one in her womb. Because events can turn so quickly, a female kangaroo can keep an embryo in suspended animation in her womb until a good food source comes along. When Europeans arrived and started pumping well water to the surface, the kangaroo population exploded out of control. The number of kangaroos is currently estimated to be approaching 30 million, larger than Australia's human population. Despite the lack of desert water, there's a surprising amount of vegetation in the red center. Like the animals, the plants found here are very unique. A quarter of Australia is covered in spinifex grass. European settlers thought it represented a fantastic opportunity to graze livestock. They were sorely mistaken. In other deserts of the world, plants have evolved water storage mechanisms to survive between rainy seasons. Such plants are known as succulents, cactus being a typical example. There are no succulents in the red center. Because of the sheer unpredictability of rainfall, storing water is out of the question. So plants here are dry, tough, and fibrous. The baking sun and wind also means that nutrients are not recycled and are leached away. It's a dusty, impoverished environment. So not only are the desert plants tough, they contain very little in the way of nutrition. Spinifex is a typical Australian plant, indigestible and nutrient poor. No good for grazing livestock. Elsewhere in the world, great grasslands are associated with herds of large grazing mammals. Wildebeest and zebra in Africa, or bison and reindeer in North America. A vital link in the food chain. In the red centre, large herds of grazing mammals are conspicuous by their absence. Australia's biggest grazer, the red kangaroo, won't touch Spinifex. Instead, it lives a nomadic life, roaming large areas looking for patches of fresh green shoots and the leaves of desert shrubs. And this requires fuel economy on a grand scale, solving one of Australia's great mysteries: why kangaroos hop. Hopping is the most energy-efficient way of getting around. Tendons in the legs act like large pieces of elastic, so that once they're moving, less energy is needed per hop. In this way, kangaroos can cover huge distances while expending the minimum of energy. So for kangaroos, Spinifex is like fool's gold. It looks like the real thing, but it doesn't deliver the goods. Despite this, Spinifex grass is home to a surprising number of creatures. To escape the burning heat of the day, most of them only ever come out at night. They're generally small, but all very unusual in their own way. They all have very Australian names too. Spinifex hopping mouse, bandicoot, and marla wallaby. One of the most unusual is the bilby, Australia's very own version of the rabbit. During the day, it lives in a cool burrow under the sand, but at night it comes out to forage. The mulgara lives almost entirely on a diet of insects. Like many desert mammals, it's developed specialized kidneys. It never has to drink, gaining all the moisture it needs from its food. The planigale is tiny, weighing only 11 grams, but will happily take on prey as large as itself. It's almost completely fearless. Well, almost. The inland taipan, the most venomous snake on Earth. One bite carries enough venom to kill several humans. Highly efficient venom has evolved here because meals can be few and far between. A swift-acting venom makes sure that nothing gets away. Being so small, the planigale is able to squeeze into tiny cracks in the ground. A lucky escape. The taipan will have to look elsewhere. Venomous snakes aren't the only challenge to life in the red centre. Dry Spinifex is a perfect place for fires to start. Occasionally, large areas of desert burn, reducing the vegetation cover to cinders. While the fires blaze, everything runs for cover, back to the safety of their burrows. Paradoxically, the destructive force of fire is a good thing for the red centre. Many desert plants release their seeds after fire and sprout fresh shoots. The ash left behind by fires puts vital nutrients back into the soil. Some creatures rely on frequent burning. The marla wallaby needs fresh green shoots to live. And bilbies flourish after fires thanks to the abundance of seeds. When humans first arrived in Australia 40,000 years ago, they soon learned that animals were attracted to recently burned areas. So they started lighting fires deliberately. This practice is known as fire stick farming and has been shown to increase numbers of desert animals such as bilby. And this animal, the desert skink. Researchers found that the desert skink thrived in areas where fire stick farming was a regular occurrence. The desert skink is unique among lizards in that it lives communally with its siblings. They cooperate as a family to dig a complex series of tunnels, safe from predators and fires. Such social interaction is very unusual behavior for a lizard. Desert skinks aren't the only lizard living here. There are more lizards per square metre of the red centre than anywhere else on Earth. Lizards are built for the Australian desert. They regulate their metabolism very differently to mammals, and as a result do not have to eat constantly. They're really good at switching off almost completely and can live on next to nothing. In the tough and uncompromising Australian desert, economy is everything. The goanna is the largest Australian lizard. There are over 20 species of these monitor lizards in Australia. They can reach lengths of over 2 metres. Goannas are active and intelligent hunters. Their powerful front legs allow them to dig in search of food, and they'll eat almost anything, even scorpions. But this has to be the most unusual desert lizard, the thorny devil. The thorny devils evolved a unique way of coping with the lack of water. The thorns on its back are not only a deterrent to predators, they're interspersed with complex ridges and channels that act as a capillary mechanism, enabling it to literally suck up moisture from the ground. Thorny devils exist entirely on a diet of ants. They have a leisurely approach to feeding. Sitting alongside an ant trail, its food is delivered straight to the door. To prevent the ants picking up on its presence, it holds its breath between meals. In this way, it can eat thousands of ants in one sitting. The large number of mammals and lizards living amongst the vast areas of spinifex are tiny compared to the countless numbers of insects. There are over 1,000 species of ant in the red centre. Meat ants get their name from their ability to pick a carcass clean. They're the most numerous species of ant in the desert, and also the most aggressive carnivore. Insects are high on their menu. A large grasshopper is quickly dismembered and carried into an underground nest. Their interconnected nests are huge and can extend for hundreds of meters under the desert floor. For an indigestible plant containing very little nutrition, spinifex supports a huge number of animals, far more than can possibly be explained through unpredictable periods of fire and flood. So what is the key to all the abundance in our microworld? What converts all this plant energy into animals? Well, there are spinifex eaters here. Millions and millions of them, and their handiwork litters the red centre. You just have to think small. Termites. Termites make short work of spinifex, converting a huge amount of plant material into body tissue. Termites are crucial to the health of the desert. They act as bioengineers, constantly turning over the soil, excavating, building, breaking down and aerating. This increases the turnover of precious nutrients and improves the soil's water-holding properties. Their gut bacteria also fix nitrogen from the atmosphere. This ultimately ends up in the soil, encouraging the growth of more plant material, including spinifex. So termites and spinifex are dependent upon each other. Termite mounds are a fortress against desert extremes. In the face of this unpredictable environment, they remain constant. The carefully crafted network of tunnels maintains a steady temperature. There's a myriad of squatters and freeloaders living in the complex tunnel system of the mound. Spiders enjoy the cool conditions. Centipedes enjoy a diet of termites. And the knobtail gecko enjoys a diet of centipedes. So, termites are the basis of the food chain. They support a huge number of animals. It's not just about food either. Goannas lay their eggs in termite mounds. A perfect incubator and a safe haven from predators. When the time's right, they just break out. In all likelihood, the total number of termites in Australia weigh more than all the kangaroos. This is environmental engineering on a vast scale. Without the unique relationship between termites and spinifex, our microworld would be nothing more than sand. Instead, life thrives here. Millions of years of isolation, drying, and uncertainty have shaped the red centre. It's the most extraordinary of environments, home to a cast of equally extraordinary animals and plants. Despite having all the odds stacked against it, the red heart of Australia continues to beat through heat, drought, fire and flood, bringing us a unique collection of awe-inspiring landscapes and wildlife.